Alright, so here we have two resistors in series. So we have a 5-volt supply, which is feeding into a 1 kilo ohm resistor, which is then going into a 3.3K resistor. So I have a 1.0K resistor and a 3.3K resistor. So I have a total of 4.3 kilo ohms. So when you see the current now, you can see that the current is about 1.14 milliamps. We have 5 volts divided by 4.3K, and so you can see the current is just slightly more than a milliamp. So it's about 1.2 milliamps. Remember, when you do your Ohm's law calculations, you need to make sure that you're using the actual measured values of the resistors and not just the color-coded values of the resistors. All right, so we see we have this current is 1.13 milliamps. I'm measuring the current by coming directly out of the power supply into the current connection, of the meter, and then out of the meter into the top of the circuit. If I wanted to, I could disconnect the meter from the top and put the meter, I'll put it in this jumper where the two are jumpered together, just to show you that the current is the same everywhere inside of a series circuit. So I'm going to connect that in there where that jumper was. So I removed both ends of the jumper and replaced it with the two ends of my meter connection. And again, we can see there's about 1.14 milliamps in the current. All right. Now, if we look at the voltage, again, this first resistor here is a 1K, and this other resistor is a 3.3K. We have 5 volts supplied. So if we look at the total voltage, we have 5.01 over here on this meter. We can see 5.01 volts, so it's basically 5 volts there. Remember, you always want to set it with your meter and not your display, because the display is reading 5.1, not 5.01. But so from ground to the positive of the power supply, it's 5.01 volts. If I measure just the 3.3, it's actually measuring 3.77 volts. Okay, so that's 3.77 volts. And if we measure the 1K resistor, it's 1.128 volts. Okay, so 1.128 volts for the 1K resistor and 3.77 volts for the 3.3K resistor. All right, so just before we do our Ohm's law calculations, which actually I should have done at the beginning, we want to measure the actual values of our resistors. So we're going to disconnect our power supply. We'll turn off the power supply. We'll disconnect the circuit. So the whole circuit is disconnected, and we'll measure the resistance. So I'll change my voltmeter into ohm meter mode, and I'll measure the resistance, that 3.3. Must have the wrong lead connected. There we go. Got the wrong lead connected. All right, so we're going to measure and so the 3.3 is 3.309 kilo ohms. 3.309 kilo ohms. The 1K is 0.990 kilo ohms, or 990 period ohms. Okay, so those are the values. So when I do my calculations for currents and voltages using Ohm's law, we see that those match. All right, so but again, when we if we connect this up, if we connect this circuit up with 5 volts applied, and we measure the voltages, okay, Kirchhoff's current law, or excuse me, Kirchhoff's voltage law tells me that the sum of the voltages around the loop is equal to 0, or the supply voltage is equal to the voltages dropped across the resistors in a series loop. All right. So again, the supply voltage is 5.01 volts. Okay, notice I got the negative lead at the top, so that's why I'm getting a negative sign on my voltmeter. But we look at the voltage here, it's reading like 3.86 at the moment. And then we look at this voltage and it's 1.15. So 1.15 and 3.85 is going to add up to 5 volts. So the sum of the voltages is equal to 0. So we have the supply voltage, and then we are dropping 1.1 volts across the 1K, and 3.7 volts across the 3.8 whatever across the 3.3K. You add that up, and you get your supply voltage of 5 volts.